As part of Linux device drivers programming language, today's the topic and session is about character device driver. And the agenda of this session is introduction to Linux character device driver flow, creation of device numbers and device files, practical program of character device driver, implementation of character device driver. Introduction to Linux char device driver. Basically, a character device driver is one of the one that can be accessed as a stream of bytes. Means like it is characterized into three parts like character device drivers, network drivers, and block drivers. As part of this session is character device drivers, and the character drivers is a sequential, character oriented, byte oriented. Means the stream of bytes will be traveled in a byte form. Like examples, we have serial drivers, terminals, etc. Like serial drivers, we can have audio display drivers, camera device drivers, and UART sensors. There are so many are there, etc. And the only difference between the character device driver and the regular file is that um, in character device drivers, once read or write is happened, we cannot retrieve back. Whereas in normal file, we can retrieve back. That is the mainly difference between the character device drivers and the normal device files. Because in Linux, everything is a file. Even the hardware is treated as a file. Let's see the basic cat device driver flow. How the flow happens from application to hardware. We can have this applications in user space that will be interacted with the device nodes or device files that will be interacted to major number and minor number and the device driver and that goes to the hardware. Here in user space we'll create the device files or device nodes, and major number and minor number is that major number that the driver will be bonded with the device, and minor number is that it is used by the kernel which driver it will be referred, which will be used. And let's see here the flow like complete connection from user space to hardware part of the character device driver flow. And we have divided this into user space, kernel space, and the hardware part. And in kernel space we have high level drivers, that is OS specific high level device drivers. And down we have the Linux device drivers that is specific to the device. Each device has a driver that is a low level driver, we'll call it as. And in user space we have applications and also libraries, and that applications will be interacted with CDF, that is character device file, and through this CDF that will be entered into through system call interface, it will be entered into kernel. And the flow will be like this: through system call interface it will be interacted to CDD, character device drivers. How the CDF and the CDD connection will be like major number and the minor number. Through major number and minor number that will be interacted with CDD. And the CDD and the CDF how to interact with like we have the virtual file system, like we have cdev underscore add and cdev underscore init that will be registered with the character device drivers. And in CDD and it will be interacted to low level driver through platform registrations, through data structures it will be happening. And from low level device drivers to hardware, that will be happening through communication protocols. If the sensors is connected using I2C protocol, that uses I2C protocol. We can have examples here: keyboard, mouse, joysticks, microphone, webcam, scanner. So based on how the connections is established, it will be used as a communication protocols. And in full level, full course content, it will be explained thoroughly, and in deep we can explain. I can explain. And the kernel APIs and utilities used in this driver code will be like register underscore caddev underscore region, alloc underscore caddev underscore region. This will be used for the creation of device numbers. Register underscore caddev underscore region is used as a statically, and alloc underscore caddev underscore region is used by the kernel dynamically. And cdev underscore init and cdev underscore add. This makes for the character device driver registration with the virtual file systems. And we have using the device files for creation. This will be used as class underscore create and device underscore create. There is a spelling mistake here, device underscore create. And kernel APIs and utilities used in the driver code. Like whatever we are creating, that needs to be destroyed, like at the time of deletion. Similarly, we have cdev underscore init, cdev underscore add. Similarly, we have cdev underscore delete. Like we are registering the character device driver, we need to unregister it. And we are creating the class and destroy the class, and device creation and device destroy. And full course content details you can contact WhatsApp number here displaying. Thank you.